Okay, good day. This is a continuation on the series of videos which I have started sharing since last week on the subject matter of trigonometry. This time we will have the trigonometric function values of acute angles. So every time we do introduce a concept in trigonometry, we always go back to the definition of an angle in trigonometry. So an angle in trigonometry, which is an angle drawn in standard position, is an angle whose vertex is at the origin and whose initial side lies in the positive x-axis. Non-negotiable. Balik-balik lang gina siya. So, it's here. Always label which is the x-axis and which is the y-axis. Again, an angle is in standard position if its vertex is at the origin and its initial side lies in the positive x-axis. For example, if the terminal side of angle theta is found in quadrant 1. Okay. The vertex is at the origin. The initial side lies on the positive x-axis. This arrow indicates that this side is the terminal side. So this is angle theta. In the terminal side of angle theta, we pick a point. This point is x, y. The x-coordinate and the y-coordinate respectively. From the point which is contained in the terminal side of angle theta, we draw a line segment which is perpendicular to the x-axis. When we say this line segment is perpendicular to the x-axis, meaning that with this line segment and with the x-axis, it creates an angle that measures 90 degrees. So this is a right angle. Let this side of the right triangle, since we already have a right triangle, let this side of the right triangle be denoted by the variable y. Since this side is parallel to the y-axis, then this must be denoted by the variable y. Like, if you are to draw another line segment from this point up to this point, you will now have a parallelogram. And take note that in a parallelogram, opposite sides are not only parallel, but at the same time, they are congruent. So whatever the measure, or whatever the measure of, or the length of the line segment from the origin up to this point will be the same measure of the line segment that is perpendicular to the x-axis, since these two line segments are parallel sides in a parallelogram. Okay, that is if you are to draw another line segment connecting these 2 points. This is y, and of course this is x. Opposite the largest angle is the longest side. The longest side, which is denoted by the variable r, is actually the distance from the point that is contained in the terminal side back to the origin. Okay. So we always have an angle in standard position every time we introduce a concept in trigonometry. And based on our previous discussion, we have already discussed the definition of the 6 trigonometric functions. So sine theta is defined as y over r. Okay, take a look. Inasmuch as angle theta is concerned, what is the side of the right triangle which is represented by the variable y. Obviously, it is the side opposite, while r is the hypotenuse, which is the longest side. The longest side is always opposite the largest angle. The largest angle is the angle that measures 90 degrees. Next to sine theta is cosine theta, whose definition is x over r. So if y is side opposite with respect to angle theta, x is side adjacent with respect to angle theta. R still its hypotenuse. Next is tangent theta, defined as y over x. So that side opposite over side adjacent. You must be familiar with the acronym SOHCAHTOA. Students have already been hearing about SOHCAHTOA, however, they don't really understand it that much. So I hope that at this point you already have a good understanding in as much as the trigonometric function values or trigonometric functions are concerned. Then you have the cosecant theta, defined as r over y. Take note that cosecant theta is the reciprocal of sine theta. So that would be hypotenuse over side opposite. Next is secant theta, defined as r over x. Secant theta, which is r over x, is the reciprocal of cosine theta. Hence, it is hypotenuse over side adjacent. And then, cotangent theta, defined as x over y, or side adjacent over side opposite. So these are the 6 trigonometric functions for acute angles. Let us now proceed to an example. Okay. Example. You are to find the 6 trigonometric function values of angle A and angle B. Okay. Again, the instruction is to find the 6 trigonometric function values of angle A and angle B, given that you have triangle ABC. So, given triangle ABC, wherein C is the right angle. C is equal to 90 degrees, or the measure of angle C is 90. Usually, in trigonometry, if you are to name the right triangle as triangle ABC, usually C takes the 90 degrees, or C is the right angle. That is actually what I have noticed. So let this be angle A, B, and then C. C is 90 degrees. Opposite the angles A, B, and C are the sides, namely A, B, and C. Okay, that's the standard way of naming the sides and the angles respectively. Side A is opposite angle A. Side B is opposite angle B. While side C is opposite angle C. Therefore, side A can also be named as line segment BC or line segment CB. Side B can also be named as line segment AC or line segment CA. While the hypotenuse or the longest side, which is opposite the largest angle, angle C, may also be named as line segment AB or line segment BA. Okay. Given that in triangle ABC, angle C is equal to 90 degrees, A is equal to 12, for example, while B is equal to 5. A is equal to 12 while B is equal to 5. So find C. C is equal to the square root of the sum of A squared and B squared. A squared is equal to 144 while B squared is equal to 25. When you take the sum of 144 and 25, you will get 169. And the square root of 169 is 13. Actually, the square root of 169 is positive 13 and negative 13. But of course, you will immediately discard negative 13 because C is the hypotenuse. And there is no such thing as negative measure for the length of a side of a triangle. So it's always positive. So C is equal to 13. Okay. Do you follow? Now let's proceed. One thing that I missed to say. C is equal to 90 degrees. Take note that when you take the sum of all the angles of the three angles in this triangle, actually in any triangle, the sum of the three angles is equal to 180 degrees. Now, since C is equal to 90 degrees and the sum of the three angles is 180 degrees, it follows that A plus B is equal to 90 degrees. Or, angle A and angle B have a sum of 90 degrees, meaning to say the two angles A and B are complementary angles. Two angles are complementary if and only if their sum is equal to 90 degrees. Okay, that's the concept in geometry, di ba? Which we can extend here in trigonometry. A plus B is equal to 90 degrees. Now, let's proceed in finding the six trigonometric function values. So, since we have sine of angle A. The sine of an angle is defined as side opposite over hypotenuse. So, the opposite side of angle A, which is line segment BC or side A, is 12 over the hypotenuse, which is 13. Follow? Then you can always replay the video if you want. Cosine of angle A. The cosine of angle A, which is side B or line segment AC, is 5 over the hypotenuse, which is 13. So, cosine of angle A is 5 over 13. Tangent of angle A. Side opposite over side adjacent. That would be 12 over 5. Cosecant of angle A. Cosecant of an angle is the reciprocal of sine of the same angle, meaning to say, cosecant of angle A is 13 over 12, since sine of angle A is 12 over 13. Secant of angle A is 13 over 5, since secant of angle A is the reciprocal of cosine of angle A. Cotangent of angle A is 5 over 12, since cotangent is the reciprocal of tangent. So these are the 6 trigonometric function values for angle A, given that in triangle ABC, side A is 12, B is 5, while C is 13. Okay. But actually, if you are to go back to the instruction, you are tasked to find the 6 trigonometric function values of angle A and of angle B. So these are just for angle A, the 6 trigonometric function values. So if you are to find now, say sine of angle B, sine of angle B using the same definition, SOHCAHTOA. So sine of angle B is side opposite over hypotenuse. That would be 5 over 13. Among the 6 trigonometric function values for angle A, which do you think is equal to sine of angle B? So as per observation, you can then say that since cosine of angle A is 5 over 13, therefore sine of angle B would be equal to cosine of angle A, because both of them are equal to 5 over 13. Diba? That is what you call as the transitive property of equality. Like what Abraham Lincoln said, that two things which are equal to another thing are equal to each other. Again, two things which are equal to another thing are equal to each other. Okay. That's in history, di ba? When the president said that because during that time there was racism. According to President Lincoln, the white are equal to the black because both the white and the black are created by God. So two things which are equal to another thing are equal to each other. Two things, cosine of angle A and sine of angle B, which are equal to another thing, which is 5 over 13, are equal to each other. Cosine of angle A is equal to sine of angle B. If you are to continue, next is cosine of angle B. The cosine of angle B, using the same definition, adjacent over hypotenuse, it would follow that cosine of angle B is 12 over 13. Completing this, di po ni siya table, completing the illustrations. Next is tangent of angle B. Tangent of angle B, which is opposite over adjacent, that would be 5. That is 5 over 12, which is equal to cotangent of angle A. Next, cosecant of angle B. Cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. Since sine of angle B is 5 over 13, cosecant of angle B is 13 over 5. And 13 over 5 is equal to secant of angle A. It follows that secant of angle A is equal to cosecant of angle B. Okay, next. Secant of angle B. Secant of angle B is the reciprocal of cosine of angle B. Since cosine of angle B is equal to 12 over 13, it follows that secant of angle B is 13 over 12. 13 over 12 is equal to cosecant of angle A. Therefore, secant of angle B is equal to cosecant of angle A. Finally, you have cotangent of angle B. Cotangent is the reciprocal of tangent. Since tangent of angle B is 5 over 12, it follows that the cotangent of angle B is 12 over 5, which is equal to tangent of angle A. Okay. Now, what we have right now is the general statement that sine of angle A is equal to cosine of angle B. Cosine of angle A is sine of angle B. Tangent of angle A is cotangent of angle B. Cosecant of angle A is secant of angle B. Secant of angle A is cosecant of angle B. Cotangent of angle A is tangent of angle B. These are actually called co-function identities. E, di ba? Ang sine, ang iyang co-function is cosine. Hence, it is called cosine because it is the co-function of sine. Ang tangent, ang iyang co-function is cotangent. While ang secant, ang iyang co-function is secant. So, the pairs of co-functions in trigonometry would be sine and cosine, secant and cosecant, and then tangent with cotangent. Tangent and cotangent at the same time, apart from saying that they are co-functions, they are also reciprocals of each other. But don't be confused because the reciprocal of sine is cosecant, but the co-function of sine is cosine. Again, mo nang gitawag siya og cosine kay it's the co-function of sine. Okay. Sine of angle A is cosine of angle B. Cosine of angle A is sine of angle B. Now, kanina we have established that in a right triangle ABC where C is equal to 90 degrees, the sum of the two other angles, these two other acute angles A and B, would be 90 degrees. Or angle A and angle B are complementary angles. Again, their sum is equal to 90 degrees. Therefore, sine of angle A, which is equal to cosine of angle B, would be cosine of 90 degrees minus A, because that is equal to B. B is equal to 90 minus A. If A plus B is equal to 90, therefore B is equal to 90 minus A. Diba? That's very elementary. That's very intermediate. If you know the sum of the two angles and the first angle is A, therefore the second angle must be the sum of the two angles minus the measure of the first angle. Like if you know the sum of the two numbers, the sum of the two numbers is equal to 10. The first number is x. So the second number must be 10 minus x. The sum of the two numbers is 10. The first number is 6. The second number must be 10 minus 6, which is equal to 4. So, in algebra, if the sum of the two numbers is 90 and the first number is A, the second number must be 90 minus A, which is denoted by another variable, B. The sum of the two angles is 90. The first angle is A, then the second angle must be 90 minus A, which is represented by angle B. Substituting angle B all throughout, so you have the cosine of angle A, which is equal to sine of angle B, would be sine of 90 degrees minus A. Cotangent of angle B is cotangent of 90 degrees minus A. Secant of angle B is secant of 90 degrees minus A. Cosecant of angle B is cosecant 90 degrees minus A. And tangent of angle B is tangent of 90 degrees minus A. Okay. Wait. Let's have some exercises in application to what we have just come up with. Write each function in terms of its cofunction. Okay. The instruction is that you have to write each function in terms of its cofunction. Number 1, cosine of 48 degrees. Cosine of 48 degrees. That would be equal to what? In terms of its cofunction. Take note that the cofunction of cosine is sine. Sine, cosine. Cofunction. Okay. Diba logical? Sine, cosine. So, cosine 48 degrees would be equal to sine. Sine of what angle? That would be sine of the angle which is complementary to the given angle. The given angle is 48 degrees. Therefore, cosine 48 degrees would be sine of 42 degrees. Since 48 degrees and 42 degrees are complementary angles, or when you take the sum of 48 degrees and 42 degrees, you will get a sum of 90 degrees. Okay. At home, when you are to use your calculator, when you are to use your scientific calculator, you may verify whether or not cosine 48 degrees is indeed equal to sine 42 degrees. How do you do that? You take the cosine of 48 degrees. You input for cosine 48 degrees in your scientific calculator. Set that aside. After that, you also input sine 42 degrees. Later, you do the comparison. You compare the values. You compare the value of cosine 48 degrees with the value of sine 42 degrees. What you will have to find out is that the values are equal up to their last decimal place, because cosine 48 degrees is really equal to sine 42 degrees because they are cofunctions, and that cosine is the cofunction of sine, and that their angles are complementary. You follow? Just make sure that your scientific calculator is in degree mode. Kanang yung calculator naman ay mode nga DRG, degree, then radian. Kanang G, gradient. I'm not so sure about that. I will have to tell you about it later. Degree, radian. Kanang DRG, kanang sa D og R. For you to ascertain, by the way, okay, usually this is the most common type of error to students who are using their calculators. By the way, when you are to use your calculator, it is your calculator that is answering, but you are still the one thinking, because whatever you input to the calculator, your calculator will simply just show you what you want it to be shown. Make sure, by the way, that your calculator is in degree mode. How do you ascertain? How do you make sure that your calculator is in degree mode? Accordingly, the best way to do that is to input sine 90 degrees. We have already discussed what is sine 90 degrees in a previous video. 90 degrees is a quadrantal angle. Diba? The trigonometric function values of quadrantal angles. What is sine 90 degrees? Sine 90 degrees is equal to positive 1. So, accordingly, if what will be shown is equal to 1, then you can be assured that your calculator is in degree mode. Again, sine 90 degrees. That is the most common way of ascertaining or making sure that your calculator is in degree mode. Okay. Nganong dili man cosine sa 90 degrees, sir? Take note that cosine 90 degrees is equal to 0. Diba? You should not be using as a test kanang cosine 90 degrees because the result will be 0. Take note that you have not yet used your calculator. What is being shown is already 0. So, it's as if you are not doing anything. So, the best way for you to ascertain whether your calculator is in degree mode is to input sine 90 degrees. And the result must be 1. If it's 1, it's in degree mode. If it's not, then better change it. Kung di ka kabalo, you ask help from your teacher or from your classmates, because even if you are well versed in pressing your calculator but your calculator is not in degree mode, it will generate a different value other than what you really intend to get. Okay. Pero sa exam, as much as possible, you don't really use your calculator. Okay. Kato ako na itong istorya ninyo. For you to ascertain, for you to validate, for you to verify, validate, and ascertain that cosine 48 degrees is indeed equal to sine of 42 degrees. Next. If you are given with cosecant 37 degrees, how do you write cosecant 37 degrees in terms of its cofunction? So, the cofunction of cosecant is secant. Secant, cosecant. Hence, they are called cofunctions. Secant of what? An angle which is complementary to the given angle, which is 37 degrees. Okay. So, what is the complement of an angle whose measure is 37 degrees? That's 53 degrees. Therefore, cosecant 37 degrees is secant 53 degrees. Okay. Last example for this exercise. Say you have tangent of 45 degrees. Tangent of 45 degrees would be equal to cotangent of 45 degrees. 45 plus 45 is 90. The cofunction of tangent is cotangent. Okay. Thank you.